start 7th example. This example is very easy. Here it is given in a triangle ABC, D, E and F are the midpoints of side AB, this BC and AC. It is given D is the midpoint of AB, E is the midpoint of BC, F is the midpoint of AC. It's already given. But we have to prove triangle ABC. This triangle ABC, this is divided into 4 congruent triangles. This triangle is divided into 4 congruent triangles. We have to prove this triangle, this and this. All these triangles we have to prove congruent. Here I have given the name of the triangle. This one as 1, 2, 3 and 4, so that there will be no confusion. Okay. This one is ADF, 2 is DFE, 3 and 4th also. And here I am going to apply the result of midpoint theorem. I know in the midpoint theorem, if a triangle is given and midpoints, 2 midpoints are given, if I will join these 2 midpoints, I will get one line. This line would be parallel to the third line and will be equal to half of it. I am going to apply this result. Okay. Here I will write this D and F. These 2 are the midpoints. As I know, D and F are the midpoints of sides AB. D is the midpoint of AB and F is the midpoint of AC. It is given. These are the midpoint. If I join the midpoint, then this line is parallel to this one and will be equal to half of it. Half I am not using, I am using the concept of parallel line only. I will take, then I can write DF is parallel to BC by midpoint theorem. Okay. These 2 lines will be parallel by midpoint theorem. DF is parallel to BC. Now again I am using the same result. If I will take E and F are the midpoints, if I will join these 2 midpoints, I will get one line EF. Then this EF will be parallel to this line and again will be equal to half of it. Half I am not taking. I can write this is parallel to this one. Similarly, EF is also parallel to AB by midpoint theorem. One more line is also there. Here we have taken DF is parallel to this one. This is parallel to this line. Third is left. Now D and E, both are the midpoints. If I will join the midpoint, I will get one line. This line will also be parallel to the third side and also it will be equal to half of it. I am not using the result. I can say these 2 are parallel. So, because D and E are the midpoint, similarly I can write DE, this DE is parallel to AC. Again by the same result, by midpoint theorem. Okay. Now just see, if this is parallel to this one, this complete line, so I can use the result, this DE is parallel to this, and similarly this is parallel to the complete line, I can use this is parallel to this. Okay. In this parallel I will take this side in this parallelogram. And if I want to prove this parallelogram, so I will take this is parallel to this, because EF is parallel to the complete line AB. Okay. When I want to prove this is a parallelogram, I will take AD is parallel to this EF. Okay. And when I want to prove this is a parallelogram, then I will use EF is parallel to BD. It will be according to our requirement. So I can write, when 2 pair of opposite sides are parallel and equal, we can say it's a parallelogram. These 2 are parallel, these 2 are parallel. It will be a parallelogram. Similarly, these 2 are parallel, these 2 are parallel. Again it will be a parallelogram. Now in this one, these two parallel, these two parallel. So we can write this is also a parallelogram. Therefore I can write BDFE is a parallelogram. FE is a parallelogram. Also this I have taken BDFE, this is a parallelogram. Also I can write ECFD is a parallelogram. ECFD is a parallelogram, and one more is also a parallelogram, this ADENF, and ADENF is also a parallelogram. Now recall the property, when we are taking the parallelogram and we can see this is a diagonal, and we know diagonal of a parallelogram divide into two congruent triangle. For this parallelogram we will take this is the diagonal, so these two triangles will be congruent. If I am taking this parallelogram, for this parallelogram ED will be the diagonal, then these two triangles will be congruent. For this parallelogram, this EF will be the diagonal angle, this triangle 2 and 4 will be congruent. Okay. Now here I can write all the three. This first, this is parallelogram, this is parallelogram, and this is parallelogram. I'll prove the result for first in one parallelogram, and rest I'll use similarly. Okay. In parallelogram, I am taking this parallelogram. In parallelogram ADEF, DF is the diagonal, and we know, and diagonal of a parallelogram divides it into two congruent triangles. Therefore I can use triangle 1, this is congruent to triangle 2. Okay. Similarly I will write, I will not prove it again. Similarly I can write, similarly triangle 2 is congruent to triangle 3, 1 is congruent to 2, 2 is congruent to 3, and similarly these two also. Similarly triangle 2 is congruent to triangle 4 also. This 2 is congruent to 1, 2 is congruent to 3, 2 is congruent to 4. So this 2 is congruent to all the triangles. Therefore I can say all the 4 triangles are congruent. Therefore triangle 1 is congruent to triangle 2, is congruent to triangle 3, and is congruent to triangle 4. Okay, here it is triangle. Question was very easy. We use the concept of midpoint theorem. When two midpoints are given, when we will join the midpoints, we will get one line. That line would be parallel to the third side and will be equal to half of it. Here we have used the result of parallel. These two parallel, these two parallel, these two parallel. Okay. And then we have proved this is a parallelogram, this is a parallelogram, this one is also a parallelogram. We know diagonal of a parallelogram divided into two congruent triangle. These two triangles congruent, these two congruent, these two congruent. Ultimately all the 4 are congruent.
Why do I, baby, why do I?